Um, so significance test using the t-distribution. Formal, the whole 4 steps will do everything this time. Okay? So here's a problem that I got out of the book. You'll want your calculators. If you're lucky, I may even show you some things in your calculator today. We'll see. We'll see. Yeah, it could be your lucky day. Okay. So, cola bottles are supposed to contain 300 milliliters. Milliliters, ml? Yeah. Of cola. So I'm not going to say any specific kind of cola. We'll just call it cola. The cola. Okay. So apparently some inspector pulled some random bottles out of this manufacturing. And he thinks that maybe they are underfilling. So, let's take a look at what he got. So he got 299.4, 297.4, 301.0, 298 really, 0.9, 300.2, and 297.0. Okay. So he didn't get a large sample. He only got 6 bottles. And we're gonna. The question is, do we have evidence that the bottles are being underfilled? Yeah. We didn't go through and measure very much, did we? The weights and measures people, they don't care if you overfill. They only care if you underfill. Yeah. So we're going to use t-distribution with a small sample, and we'll see how we have to analyze this. Okay. So first off, we'll do our little step 1, which will be to define our parameter, and we're going to find the mean number of millimeters in a bottle of cola. So mu is the mean milliliters of cola in the why doesn't that work? In the bottles produced by this plant. All right. What else do we need to do in step 1? Do you remember? State what we're looking for. Exactly. Ho and ha, yes. Our null hypothesis, we can write that out symbolically, is that the population mean is 300, and I always like to include units here, because if I forget, this is all step 1. My alternative hypothesis, oh, thanks. Like that? Okay, thanks. So now we got to figure out what the question is asking. Do we have evidence? Where's the do we? Oh, we. Jeez. Do we have evidence that the bottles are being underfilled? All right. What's my alternative hypothesis? So we're underfilling. Underfilling is going to be less than. There we go. All right. What do you figure step 2 is? Come on. Conditions and the name of test. Okay. Yes. Shh. So your test is a significance test for a population mean. We're going to use a t-distribution because nobody gave me the population standard deviation. And this is a one sample or a single sample. Nope, different. You'll see when we get to 2 samples, and it'll actually be a couple of chapters before we get to 2 samples. So, is that what? More advanced? Is that what you said? I couldn't. Okay. Conditions. SRS. We're going to assume the inspector got an SRS, even though it was just 6. Because they're inspectors. They should be getting a simple random sample. Yeah. Yes. Good. All right. Normality. Okay. So my normality of my sampling distribution, how am I going to get normality of my sampling distribution? Box plot. Good. So anybody make a box plot of this? I can't remember if I put this in my calculator. Oh, I think I did put this in my calculator. There's no outliers. Good. Oh, sure. All right, so I'm going to say box plot shows no outliers. Yeah, you're going to draw it. And boy, it looks pretty symmetric. So mine looks like, if I put this in right, about like that. Is that what yours looks like? Yeah, that's pretty symmetric for 6, for 6 pieces of information, for 6 values. Okay, and independence. Oh, so this 6 bottles is coming from a very large population. So yeah, we can say that we have a random sample from a population greater than 60. I would bet they made more than 60 of these. Colas, sorry. Oh, 10 times 6. Yeah. Okay, so next part is do the math. So in the math, I need a test statistic. In this case, we're going to use a t-distribution, so it's a t. So it's my sample mean minus my hypothesized mean divided by my sample standard deviation divided by the square root of my sample size. What's my sample mean? No t star, no critical t on this one. That's on confidence intervals, you do the critical t. On significance tests, you just get a plain old t. All right, bald t, yes, there you go. So, anybody got a, anybody try putting this data in their calculator? Good? Oh, geez. You're saying, I need to write that a little smaller, don't I? 298.983 minus 300 over, what's that sample standard deviation?